These are the 11.13 application with standard normal distribution supplemental notes. Let's jump right into it.
In our previous lesson, we discussed the empirical rule. The empirical rule is still part of this lesson. Any type of normal distribution uses the empirical rule, which if something is one standard deviation from the mean in either directions, it adds up to 68%. If something falls within two standard deviations of the mean, it's 95%. And if everything that is three standard deviations away from the mean is 99.7%. Everything that is underneath the bell curve is 100%, or 1. Standard normal distribution is a normal distribution with a mean of 0, and the standard deviation is equal to 1. It is symmetrical about the mean. The average curve equals 1. So that means that, or the area under the curve equals 1. So that means everything underneath the curve equals 1. Same thing inside of our imperial rule. It follows the imperial rule, but instead of using the variable x, we use the variable z. And this has to do with our z score. We are going to be using this table here. This table has a column here and then rows. The first column is the first decimal point, and then the second column, or the 10th place, and then the row up top tells us our 100th place value. And we are going to be using this table to answer questions. Okay? And these numbers that are off to the side here, these would be our z-scores. So, for example, which is equivalent to p, and then z is greater than or equal to 1.4. Okay, so we're going to look at our normal distribution, standard normal distribution curve here. 1.4 would fall in between 1 and 2. And we're looking for everything that is above this amount. All right, so we need to see which one would be equivalent or the same. All right, being less than or equal to 1.4 would be everything that is rest that's left over. That would not be the case. All right, 1 minus p to the z is less than or equal to 1.4. Okay, so in our lesson that you should have watched prior to this, it told you that if we are working with greater than, we are actually going to take the less than value that we would get from our table, and we're going to subtract it from 1. So we would take the 1.4, which is 90 or 0.9192, and then subtract that from 1, and that would give me my value. So B is the correct answer, because it would be everything that is less than this amount minus 1, which would be what is left over, which is this amount right here. Let's just make sure it's not the last one. Negative 1.4 and then greater. No, that would be too much. If it was less than, then that would be a true statement, but is not. All right, use the standard normal table to find p is greater than 1.4. Okay, so like I said beforehand, we are going to take, or we're going to look at 1.4, and we're going to take this value right here. And we're going to subtract it from 1 using this equation right here. So we're going to take 1 minus, and we're going to do 0.9192. And we are going to get 0.08 approximately. And then we are going to make this a percent by moving it back 2 decimal places, and we will get 8%. Okay. What is the range between 0.06 or z is greater than or equal to 0.06 and less than or equal to 2.16? Okay, so what I'm going to first do is take my 2.16, the larger number, and I'm going to find its score in our chart. Okay, so 2.12. Okay, so I'm going to look 2.1, and then I got to go to the 2 column. So that's 0.9826. So I'm going to take 0.9826, and then I'm going to subtract the value that I would get from 0.06. Okay, so 0.06, and there's nothing afterwards, so that's 0.7257, 0.7257, and I'm going to subtract those, and I'm going to get 0.2569, which rounds to 26%. All right, let's look at the next one. The life of a manufactured computer fluorescent light bulb is normal, with a mean of 12,000 hours and a standard deviation of 2,000 hours. Seth wants to find the probability that a light bulb he purchases from a manufacturer will last no more than 14,500 hours. Okay, so what is the standard deviation above the mean? Okay, so let's fill in our chart first off. Let's make our standard deviation table. So our mean is 12,000, so that's going to go at 0 because that's where our mean goes. And then if we were to add one standard deviation, this would be 14,000. Two standard deviations would be 16,000. Three standard deviations would be 18,000. And if we work backwards, it would be 10,000, 8,000, and 6,000. So a standard normal distribution bell curve here uses the z-score. And to find our z-score, we take our amount, subtract the mean, and divide by how many there are. So that, or divide by the standard deviation. So that's what we're going to do. So I'm looking for 14,500 minus our mean, which is 12,000. And I'm going to divide by our standard deviation, which is 2,000. So I'm going to get my z-score of 1.25. So that would be 1.25, approximately here. All right, and we're looking for everything that is less than or equal to 1.25. So that's everything is this way. So we just have to use our chart. We do not have to subtract this from 1 because it's not greater than or equal to. It's less than or equal to. So I'm going to go up to my chart and look at 1.25. So we're going to do 1.2 and then we're going to do 5. So this is 0, 1, 2, 3, 4, 5. Let's just make sure that's in the 5th. Yep. So 1.25 is going to be right here, which is 0.8944. So 0.8944 is 89%. Let's look at this last one here. Which of the following statements is equivalent to z is less than negative 0.21? Okay, so negative 0.21 is approximately here, just right afterwards. We're looking for everything that is less than or equal to. Okay, so we're looking for the small amount. Okay, z is greater than negative 0.21. 0.21. No, that would be everything that's left over, so no. Okay, 1 minus z is less than 0.21. Okay, well, let's think about that. All right, so we're looking at 0.21. That's right here. And everything that is less than minus 1, which would give me my remainder of this amount right here. Isn't this amount right here the same as this amount right here? Yes, because they are symmetrical. So B is my correct answer. They could have also given you anything that is greater than 2.1, but not subtracting from 1. So we're looking for B there. So then let's see. Use the answer from the previous task to determine z of negative 2.1. So in order to find the negative, you do have to find the opposite of the positive. So we are going to take this. We're going to take 1 minus, and we're going to do the 2.1 here. And we're going to go up to our chart. And we're going to look at 2.1, and that's 98 or 0.9821. So we're going to take 0.9821, 0.9821, and we're going to subtract, and we are going to get 0.0179, which is A. Remember, if you have any questions on this lesson or topic, please send me a message in Edgenuity, email me, or give me a call.